Namaskar dosto, welcome you all in this new video, and in this video we are going to discuss about the normalization of wave function. Okay, and this is very important in quantum mechanics. If we are discussing about quantum mechanics about the wave function, okay, so normalization also come into influence while wave function studying and probability density studying. Okay, in the previous section or previous video we discussed about the wave function. Okay, and we know that what is this wave function means, that is represented by psi, and we also discussed about the probability density. Okay, that is represented by the psi square. Okay, so it gives the density to us of a particle in a particular region. Okay, and wave function just give us the probability. Okay, how much there is probability to finding a particle in a particular region. Okay, and this wave function also represent the character or that material wave existed with that particle. Okay, so let's start our video and understand the concept of normalization of wave function. Okay, so let me change the color. Okay, let's start. If we talk about the normalization, okay, normalization, what does normalization mean? Simply it means that probability of a particle in overall space is 1. Okay, it means that if we are going to find the probability of a particle in a particular region, okay, so what will be the probability comes out, that will be 1 in the whole region. Okay, so if we had discussed about the probability density, okay, that is equal to the integration from the minus infinity to plus infinity. Okay, and then there is wave function and complex conjugate of the wave function product. Okay, and d, let this is along the one axis, that this is along the x axis, so this will be equal to 1. So this is the mathematical expression for the normalization of wave function. Okay, so if this condition is satisfied by any wave function, that we can say that that kind of the wave function or is normalized. Okay, normalized means total overall integration over the whole space is 1. Okay, so how, let's discuss proper about it, mathematical expression. Okay, mathematical expression for normalization of wave function. Okay, normalization of wave function. Okay, mathematical expression for normalization of wave function. Okay, so what is the mathematical expression? It states that minus infinity to plus infinity means what? It is the whole space. Okay, it is not, there is no any limit how much larger is that space. Okay, that will be minus infinity to plus infinity. Okay, so there is the first wave function that depends upon x and t, and the complex conjugate of that wave function. Okay, x and t, x and t is the parameters, okay, on the which this wave function depends. Okay, and this is about, we are talking about the three-dimensional space. Okay, we are talking about only x-axis now in this space. Okay, so this is equal to 1. It means that the to finding the particle, okay, in overall space, in this expression we are discussing only x. Okay, if we are discussing about the whole space, whole three-dimensional, then we will put r in the place of this x. Okay, why? Because r represent all the three x's. Okay, so this is the mathematical expression. What does this mean? This said that product of the wave function and complex conjugate, okay, over the whole space and integrate that, okay, that is equal to 1. Means the probability of finding the particle in overall space, that is equal to 1. What does the we also know that, okay, let when there is a condition, when the probability is equal to 1, what does this mean? It means that there is the definitely occurrence, okay, of the event. Means it is 100% sure that there is particle inside that region. Okay, and it's definite. So this, that is why this kind of the behavior is represented by the wave normalized wave function. Okay, or normalization. Now discuss about what is the condition if there is a question that this is the wave function given to you, and show that this wave function is normalized. Okay, let first of all this is given to you, and this is unnormalized, not normalized. Okay, not normalized. Normalized, not normalized means the product of the integration of the product of the wave function and complex conjugate of this wave function is not equal to 1, that is equal to something constant. Okay, like this, let this is not normalized means minus infinity to plus infinity. Okay, this is the complex conjugate, and dr3 is equal to n. Okay, so this is the condition given to you. Okay, you have to prove that or make this thing normalized. Okay, make this psi, let this is psi given to you, make this uh, normalized wave function. Okay, so what will we do? We will divide both side by n. Okay, so this will be the condition that will arise. So by this dr3 is equal to 1. Okay, now put n here and here. What will you do? So next will become psi over delta n psi n. Okay, so this is from minus infinity to plus infinity, and dr3 is equal to 1. So this is the normalized wave function. Through means what? If there is a wave function that is not normalized, okay, so how we can make that function normalized? Okay, we will normalize that thing by dividing or with the help of n. N is what? Normalization constant. Okay, normalization constant means what? That is the constant or the value, okay, something whatever it will be, which makes by dividing or by multiplying that n with that wave function, okay, that is turn out into the normalized wave function. Okay, this is the condition. We have to satisfy this condition to prove that either that function is normalized or not normalized. Okay, so this is about normalized, and in the next video we will discuss about the examples. Okay, what are the example and where we can apply this thing, okay, and how we can prove that particular wave function is normalized or not. Okay, so in this video we just discussed about the normalization. Okay, I hope you like this video. If you like our video, then give a thumbs up and do subscribe our channel. Thank you so much.